So in part 2 of this tutorial, we're going to look at wave interference from a two-dimensional standpoint to understand how you can get patterns of constructive and destructive interference based on path difference. All right, path difference has everything to do with phase. It's not a difficult concept, but it's just a new vocabulary term. So we're going to look at waves not on a one-dimensional standpoint, like little wiggles. We're going to get them like ripples in a pond. And so you can see this looks like a fairly complex pattern below. But once we learn how to decipher it, it's not too bad. So we're going to do a few points together, and then I'm going to let you do some on your own and do a practice problem in this. All right, so we have two sources of waves. They could be sound, they could be water waves, S1 and S2, and propagating from them. You can see here they're alternating crests, troughs, etc. And if you look at the key, you see where it says dark, it's a crest, and where it's a trough, it's light. And I've chosen various points in the field and try to look at whether we have constructive or destructive. So the easiest way to recognize constructive or destructive is just to see is a crest meeting a crest or is a trough meeting a trough. That's constructive. And if a crest meets a trough or a trough meets a crest, then we have destructive. And then we want to find a pattern there. So let's take, for example, A. A is, look right here. All right, we see that there's two dark lines intersecting. So that's constructive interference, which I'm going to call CI. If we look at B over here, it looks like two light lines are meeting. So those are two troughs, but that's still constructive. Okay, and if we look at C, those are definitely too dark. Constructive interference. Oh boy, are they all constructive? And D, all right, this is a little less obvious, but if I look at this point right there, that looks dark. This one looks light. So D looks to be destructive interference. And let me choose one more. Let's look at F. F seems to be dark versus light. So let's call that destructive interference. I'll let you do E, G, and H. Now let's look at the concept of path difference. Okay, path difference is exactly what the term means. It's how much difference there is in the distance the wave has traveled to that point from the other one. So for example, let's take point C because that's already drawn for you. If we go from point, S1 to C, we can count the number of wavelengths. Now, it's already labeled as 4 wavelengths, but let's make sure you understand where that comes from. If I start here, here's a trough. I'm going to go by crest. So here's one crest, the second crest, the third crest, the fourth crest. So that's 4 wavelengths away. And if I go from 2, I've got 1 crest, 2, 3, 4, 5, 6. So my path difference for C, I'm not going to use it as a 6 minus 4, which is 2 wavelengths. So when you're 2 wavelengths difference in path, we get constructive interference. So let's do it the same for the ones that we've already marked as constructive and destructive, and I'll let you do it on your own, but we should see a pattern. All right, so let's look at A. A is right between the two, smack in the middle. So we should be able to figure out that it's a 0 path wavelength, 0 different path length. But let's just verify. Start here, we got 1, 2, 3. From S2, 1, 2, 3. So that's really just 3 minus 3 is 0 wavelengths. Okay, so we see there are different path differences for A and C, but there's still a pattern to it. All right, how about B? Okay, so B, it's a little bit more difficult, but I think we can do it. So I'm going to start from 1. We have 1, 2, 3, 4, 4.5. I haven't got quite the next dark one, so it's 4.5. I'll call it 4.5. And from 2, notice we have to travel further to B. So we got 1, 2, 3, 4, 5. So not quite. So 4.5 minus 5 is a half. Did I count that right? Let me make sure I did that right. It looks like there might be 6. 1, 2, 3, 4, 5. Yeah. And this one is 1, 2, 3. Sorry, do that again. 1, 2, 3, 4. Okay, so I miscounted B. My bad. So that is 5 minus 4, which is 1 wavelength. Silly me. So this is 3 minus 3. This is 6 minus 4. All right, so what we notice for all the constructives is even though they're different path lengths, what they have in common is that they are an integer value of the wavelength. So that's an important rule. The maximum constructive interference was when the path difference, delta lambda is what we call path difference, is equal to an integer number of wavelengths, 0, 1, 2, 3, 4. Okay, so let's look at D, which is destructive interference. Well, it can't be 1 or 2 or 3 wavelengths away or difference, so it's got to be something else. We could probably anticipate what it is, but let's count it out. We have 1, 2, 3, 4, 4.5 from this one, and from S2 we've got 1, 2, 3, 4, 5, 6, 7. All right, I'm pretty sure of that. You guys can count and correct me if I'm wrong, but the difference there is 2.5. And if you look at F, which is also destructive interference, okay, I'll do this in blue. Might be getting messy for you. 1, 2, 3, 4, 5 from S1, and from here 1, 2, 2.5. So 5 minus 2.5 gives us 2.5, and so it's a coincidence that these two are the same path difference. But what matters is that the path difference, delta lambda, is a half integer wavelength, m plus a half lambda. Okay, so when we have that, we get zones of destructive interference. So I'll leave it for you to do E, G, and H. And then the nice thing, what we should notice is when we put it all together, I only chose 8 random points in this field. But if we look at all these dots on this diagram down here, you will see alternating constructive, destructive, constructive, destructive, etc. I'd like to be able to label that. It's going to get a little bit messy here, but the arrow lines are all constructive. Okay, and the dots between them are destructive. On the board, obviously they're color coded. You don't have that. And the nice thing is we can put the path differences. So right down the middle is 0 wavelengths. Here it's 1 wavelength, 2 wavelengths. We can call this 1 wavelength, 2 wavelengths. And then between them, it's not hard to figure out 1.5, a half, so on and so forth. Okay, so that's a really important relationship to understand about constructive and destructive. So a simple little problem, or maybe not so simple, but once we do it, you should see that it's not too bad, is let's say I have 2 speakers that are in phase with one another, and I'm sitting right here listening to both. So I'm picking up sound waves from both of the same wavelength. Now I want to know, is this going to be louder or softer? In other words, is this a zone, minus spot of constructive or destructive interference? So in order to do that, I got to find the path difference. Okay, so path difference is the number of wavelengths. Well, you're told that the wavelengths here is 1 wavelength is 1.6 meters. So from 2.4 meters away, that's 1.5 wavelengths. And then the distance from here to here using Pythagorean theorem, I believe is, 6, 8, 10, 40, 4.00 meters. And 4.00 is 2.5 wavelengths. Okay, so that's 4 meters. So path difference, delta lambda, is 2.5 wavelengths minus 1.5 wavelengths, which is 1 wavelength. And that is constructive interference. So the person chose wisely. They have a zone where it's particularly loud, which is what they probably intended. Okay, so we'll have practice with this, and hopefully it'll all come together for you.